Okay, let's talk about this question, 1044, longest duplicated string. So the question is, we look into a string, find out which substrings have been duplicated, or we have two of these substrings. For example, we see A and A here once and two, so we have two of that. The question asks us to solve it. The brute first way to do it is gonna go through the subarray or create all subarrays, see if you see any duplicates, and then choose the longest one. But for sure, this is not the best time solution. We are looking for something much more optimized. If you go through the hint, it's gonna tell you, okay, binary search. What does that mean? It means that, for example, let's say this is 1, 2, 3, 4, 5, 6. We can say, okay, do we have any um, sub duplicated substring with length of 3? If the answer is yes, then we can go and check for the higher numbers. If the answer is no, using the uh, binary search algorithm, we can go for something and check lower. I would go through this response. I think that's the best answer. So his answer has two parts basically. One is doing the binary search, as you can see. Okay, he has started from beginning to the end and then calculating the mid. So, and then the hardest part is, okay, let's say we choose number 3 or 4 or whatever number we choose. We want to see if the duplicate substring exists or not. What should we do? There are a couple of ways to do that. One way is using try, but I think try node is not that much optimized here. This guy is talking about different ways. Yeah, you can solve it with try, but my understanding is it's gonna fail. It's not gonna be optimized as this one. The other one is KMP, which is again even harder. So the best way to see what you do is using this algorithm, Robin Karp string matching algorithm. So if you know this algorithm, I think we are in a good shape to start. Basically, the whole thing is we are gonna say we should have a hashing function, and this is our hashing function, and then we are gonna see if we have it on the string we are looking for. So if you know what is mm, Ro- Robin Carp or whatever they want to call it, I think we can understand here what's going on. However, there are still some issues. One is why the one we are getting mode of Q. That's because the numbers are gonna get really large, and by finding the mode of Q, then we are decreasing the numbers. The issue with that is, as Abdullah in the other video is saying, is or Abdul is, I think, yeah, Abdul is saying, um, is we are gonna increase the chance of collision. So Q should be as high as possible. I think here they explain it that 31, yeah, he used 2 to power of 31 minus 1 because it's a big prime number. So uh, if we don't get the mode here, then our numbers may increase a lot more than integer, and then we are gonna get some errors. This is why uh, we get the mode by Q. Something to notice here is these equations this guy is trying to say here. When you try to find the mode of A plus B mode M, one way to do that would be we say, okay, what's the mode of A? What's the mode of B? Add them up and then find the mode of the add up. It kind of makes sense when you see what is the mode. Even my understanding is even if you can find, okay, I mean you can find the mode A plus B, but the issue is maybe A plus B is a huge number. Usually for this one, plus is usually okay, but for when you have A times B, maybe it's too large number. You don't want to get that far. So what should you do if you are getting an error here? You can find mode of A, mode of B, find their multiple times them by each other, and then find the mode again. Or you can find even mode A times B, and then you find mode of them. Here you can find their modes and then add them up and find their modes, or even you can find mode of one of them, add it with the other one, find the mode. Because here's the thing, when you just consider what's the mode, and then you understand that, okay, let's say M is 10 and A and B's are, I don't know, let's say 21 and 22. So 21 and 22 is going to be 43. So the mode is going to, when we are using 10, it's going to be 3. So the other one is, okay, here 21, the mode is going to be 1. Here is going to be 2. So 2 plus 3, 3. Mode of 10, it's going to be still 3. Hopefully that one makes sense. We should understand that part, because to understand why here we have this part. The other interesting thing this algorithm has, is ro- rolling hash map. Here, Abdul is describing what is rolling hash map, and I think I will go through that as well. So, when you find the hash map for this one, let's say you have three characters, and now you want to go to the next tree, you move it. You don't want to calculate the hash again. You don't want to go through this one again, but you want to remove the left side and add the right one side. This is why I think this solution is introducing this auxiliary value h. So each time it's deducting h here, this one is gonna be deducted, and then the next item is gonna be added. Why here he has q? Because of this example. So hopefully this makes sense. So what does he do? Here it's we are gonna give the text, we are gonna give the length. M is gonna, here is describing, M is the length that we are looking for. Q is a prime number for division. I think Q is 2 to power, yeah, this one is important to know. This means 1 times 2 to power of 31 minus 1. So what does that mean? Here it's saying it means x times 2 to power, or here x2, x times 2 to power of 1 to y, or here it's 1 is nothing, so 2 to power of 31 times 1 minus 1. That's the big primary number. Why we want to have primary number? Because if its number is not prime, because when you have a prime number, then the modes are gonna be different, so we are gonna get a better hash compared to when this is not a prime number. Okay, so the issue, okay, here is the thing. To get a, we when we find out our hash maps is working and we get to a number or matching pattern, we should check it. Maybe it's a false positive. We think it is that, but that's because of the hashing. And actually, two strings are different. So here, the larger number we have, it's gonna be better. It's gonna reduce the chance of just colliding the two, and this is why we should have a high number here, prime number here. Anyway, so here he's gonna define a dictionary of the list, and then for each number he's using this rolling hash by removing the last number, adding the new number. It's calculating its hash value. Then if they are not in dictionary, it means we don't have them, so we are good. So we are gonna add them to the dictionary. But if it is in dictionary, it's possible that's the word that we are looking for. Then it's gonna say, okay, for for all items in that dictionary. Okay, here's the thing. This dictionary has a list, so it's assuming maybe we have, let's say, we hashed something, and we have two values for this hash, or two substrings are gonna give us exactly same hash, but in reality they are not the same substring. It's possible. So it's gonna go through this dictionary, say if the word that we are hashing is the same as what we have already in the dictionary, then you can return it. As simple as that. If by end of the two for loops it cannot find anything, it's gonna return false. It means it doesn't exist. Um, yeah, I think that's the high level of what's going on. Stuff to understand are D is 256. 256 here he chooses 256 because it's more than ORD of Z. What else we are looking for? Um, T, it's calculating T. H, okay. H is this number that you should look into that carefully to see how it's been calculated and why he has H. Okay, the first thing is to find out how this T is calculated because it's using itself. So this T is this number. You should see how it's calculated, and then you should see how this hash should be calculated yourself. And for this divided mode of queue, you understand using this one how it has been calculated. I think that's it for this video.